second one. If you haven't, don't worry. But how many have tried? The right. So this is the part 2 continuation from the previous video. So those who are watching, if you start from here, you will be confused. So start from the previous video for geometry. It will cover everything up to question 3. So this is question 2 continuation. Yes, this one? No, I've just supposed to be solved, right? Supposed to be solved. That's a very good observation. So I'm just marking quickly. All right. So we are continuing from the previous video, which said find the angle difference in latitude between P and Q. We said identify 3 angles, then pick 2, eliminate one wrong. So let's do the same. Find the angle difference in longitude between point Q and U. We are using this diagram. Point Q is this one, point U is this one. These 2 are coming from different circles. So you join using the larger circle. So you join this here and you also join there. So they're looking for this angle here. That is the angle they are looking for. That's a very big angle. Right? So you can't expect to subtract the angle. That's a very big angle. You imagine an angle from north to south. That's a very huge angle. But for the sake of understanding, let's identify how many angles? 3. 3 angles. Let's identify them. The angles that are connecting Q and U. Q is, I can see 30 degrees north. You're welcome. Take a seat. Very good, right?
Yes.
Nice. I can also see 80. You can see there. Sit there. 50 degrees. That's south, right? Okay. So 30, you know what to do. Like I said, one long okay? So those who are not understanding one long, it's like there's an intruder here. We only need 2 angles. Okay, so you can eliminate. Cannot go with the east. No. Can east go with south? So definitely this is out. You've seen that. So you remain with what? 30 degrees north and 50 degrees what? When the directions are different, the sides are different, the hemispheres, you add. Because look at the angle, it's very big. Okay? So we are going to add 30 plus what? So it will give you, don't add the directions, just leave it the way it is. Now, this is grade 12 syllabus. You observe that most of the questions that you will be solving, they will be adding. But there are also questions where you subtract, but those are rare questions. So I've seen this before where grade 12s are used with the addition. So find the angle difference. What yes, it is very common with addition. But one day you will find subtraction. So take note of that. Okay, let's go to the next. Can someone check for me the content? What's next? Distance, right? Is it circumference? Okay, circumference. Circumference is the third one. Circumference. So that is number 4. Find the circumference of the small circles A latitude 30 degrees north in nautical miles. Those are units. Okay. Then B latitude 50 degrees south in kilometers. Okay. So the formula for circumference is the same. Doesn't matter the latitude, the circle that they've given you. Okay? So circumference simply means the distance around the circle. Yes. So we have 2 pi. Well, other teachers use like a small r, then yeah, but we just do direct. R cos x degrees. Okay? Yeah. But other teachers, you will discover that must go 1. For example, circumference is equals to 2 by r. That's latitude 50 degrees. Yes. Latitude 50 degrees south. And the problem right is 5. But let me try and do better. Okay, that's much better. West. So other example one abazambo kuze that akakasimu r ni capital letter r was x degrees. So it's better that I tell direct. Fine. So change what is a formula. Those who are watching, can you master that formula? Very important. It's rare they ask you about circumference, very rare. 2, they will give you the pi. Trust me, the pi they will give you. It is 3.142. It's the power 1, it's over 7. But I've never seen a question in the power 1 being asked about the circumference. But I'm not saying it's one of us, but I have named radius. Bama pass, and they will give you. They will give you. For nautical miles, it's 34, 37. Cos x is basically what you are given, the angle here, the 30 degrees. Just type, punch on the calculator. Punch. Yes, my friend. Oh, don't worry about that. This R is basically the radius of the small circle. Then now you have to transition it into the capital, but don't worry about that. Yes. Or it's the radius of the earth in nautical miles. They will give you, don't worry. They will always give you, yes. No, they actually, if they don't give you, come and tell me, I'll fool them. Yes. Good. Oh, don't worry, good. Forget. It's this one, not this one. Oh, don't worry. It's a same. This and that. They will give you the radius. If they don't give, I will sue them. Please sue them. You can sue them. Monaka in syllabus, they will give us. But don't worry, they always give. Okay? You don't have to punch. So let's punch. 2 times 3.142 times 34, 37 times cos 30 degrees. So if this calculator is original, it is giving 8704.5102. Have you found that? Okay, it's very original. Okay. Now, in mathematics, especially there are rules of how to write the final answer when you have a decimal. Okay? When you have a what? If you've answered the question, three significant what? Figures. Just count 1, 2, 3. If this was above 5 or 5, we could have written 8 here, then it is zeros. Whatever is after this decimal, forget. Just forget about it. So, yes, my friend. You forget everything after the decimal point. But the ones before the decimal point, they change into zeros. So for instance, if you write it like this, it is a wrong answer. Because you've changed the reading, you've changed the place values of this number. This number is 1, 2, 3, 4. It's about 18,000, 18,704 there. Okay? Yes, if it was like, let's say, 187, not 4 but 0. If it was like something like this, we could have written 188 will change 7800. But if it's below 5, we don't change. Above 5 or 5, it does change. Yes. Just become 0 without putting anything. It will just become 0. After the third number, whatever is inside, change them into zeros. Alright? Then you know what to do? Your exercise is to do B and C. You are finding the circumference of latitude 50 degrees in kilometers. Now I mentioned that they always give the radius in. So what is the radius in kilometers? Radius in kilometers is 63 70 kilometers. That is the radius. And then 34, 37 nautical miles. The radius. Yachalo, the radius of the earth. So change my exercise. Let's mark. I hope you have done that. B and this. So we are now marking circumference 2 by r cos x degrees 3.142. They always give this. Radius kilometers, it's what? 370 kilometers cos 50 degrees. Let's punch that. 2 times 3.142 times 6370 times cos 50 degrees. Now we are getting 2573.19665. I'm using an original calculator. If you are using a phone now, yeah. Now you can't leave your answer like this, right? You now let's round it off. 3 numbers, 3 significant figures. 1, 2, 3. So our circumference will be 257. Can 3 change 7? No. So we've got 1, 2 numbers, so they change into zeros. Kilometers. You forget about whatsoever after that. That's the first one. So similar to the other one, same formula. 2 times 3.142 times, they have said nautical miles. These are the radius. That's the radius. As you can see, cos 0 degrees. Mufunika maziva ko tuva grade 2, but G.C.E., those who are watching, that's the guy there. So when you punch this, so guys, cos 0 is always 1. Cos 0 is always what? 1. It's a special angle. So 2 times 3.142 times 3437 times cos 0, which is 1. We are getting 2159.8.108. Rounding this, it will be 2123, 21. And 9 change 5? Yes, to what? 6. And then the 9 itself becomes 0, 8 itself becomes 0. Now meaning you've rounded off with three significant what? Figures. Apatapitapo, we're almost done with this topic. Distance. Let's talk about distance. Yes. Go ahead. Okay. She's asking the reason why we put zeros, isn't it? Okay. So the reason why we put zeros to these numbers, for instance, why did we just say the answer here is 257 kilometers? Why are we adding zeros? Okay. By the way, it's not always two zeros. They can change depending on how many are remaining. Why are we not just saying 2610? So the reason is simple. This number, this distance, remember circumference, the distance around the what? Circle. When you read this, can someone try, let's try to read this. Much more like numbers in words. 25,730. So meaning that's a distance, right? Are you following? It is 25 what? 730 kilometers. That's how the distance is when you round the circle for 50 degrees. And then now you write your answer. Can you read this? Read. 200 kilometers. You see that we've changed the distance. Here it is 25,000. Here it is 250. So that's why it's not my zeros, so that you don't change the reading of the answer, the reading of the distance. Can you read? I want you to read this answer. 25,000. So mean the answer is still in 1,000. Are you getting the idea? The distance is still in 1,000. So that is the reason why we add zero, so that we don't change the reading. We don't change the place values of the answer. That's a very good question she has asked. Hope now you know what I'm ready. Send the money to Yeta mazina yezaleka. Okay. Let's move on. Let's continue. We are looking at distance. Okay? I like this part. We are looking at distance. We are how many minutes, my bro? 18. 18. So mean you're going to have part 3. Wow. Once it's 20, give me a signal. Distance. We want to talk about distance. There are two things: distance in latitude, distance in longitude. So let's master these formulas. Distance in latitude. So distance in latitude, we have theta over 360, okay, times 2 by r cos x degrees, which is basically the latitude angle. Okay. Other teachers prefer to say theta over 180 times pi r cos x degrees. These two formulas are one and the same, because I can solve 2 now 360. Whichever you remember first, it's one and the same. It's okay. Okay? Yeah. But in a papa guy, this is the angle difference. Angle difference in longitude. Don't forget that. Angle difference in longitude. But even if you forget, it's fine. Okay, so we'll continue with part 3 for this video. See you in part 3.